Perfect. If there's any question, then from my perspective, please just unmute yourself or make use of the chat. I will try to keep an eye on the chat. If I'm not answering your question in the chat, then please unmute yourself and just tell me there's something in the chat. Yeah, today's topic is advanced data modeling in Power BI. And the most important part about me is I work with models. This means if I can skip to the next slide, of course I cannot. What's the matter here? Oh, yeah, that's the next slide. So I work with models, and if I tell people that I work with models, they might have different pictures in mind. So some people think I work with beautiful people, but instead I work with beautiful data. At least after I'm finished with my task, I hope we could discover the beauty in the data and clean the data and make everything right. And a very important part in getting Power BI and analysis services right is to get the model right. So if I speak, all the demos are about Power BI Desktop because it's easy for me to set up the things. Everything is one place, right? The model, the visualization is easy for me from an educational perspective. But everything I tell you in this talk also applies to analysis services Tabular, even might be applicable to SQL Server analysis services Tabular if you still have on-premises systems running. The important part with those tools is that the tool is optimized for star schema. So when you hear people talking about star schema, star schema, star schema, it's so important. It's maybe not so much because star schema is so superior as a model over data vault or in-month concept or whatever you will find out there. They all have their places. But it's a matter of fact that Power BI and analysis services, the Vertipack engine behind, is optimized for star schema. That means you can load a model of any shape into Power BI analysis services. It will work, but you will have to pay a penalty sooner or later. That means performance-wise, that means DAX will be more complicated. That's the two consequences. And the thing is that if you discover that you did it wrongly, in a certain point of time, it might be too late to change the model. Because if you change the model, if you changed the relationships, if you remove parts of the model or split up things, most probably it will break your reports. That's why it's so important to understand the importance of modeling and to understand that it's very important that you get it right from the beginning. And that means stay away from anything else than one-to-many relationships. One-to-many relationship is the thing going for because this is what it's optimized for, and also stay away from bidirectional filters. I think there was a version of Power BI where automatically all the relationships were bidirectional. Please don't do that. Please think about that. And again, if you change this later on, most probably it will break your report. So you have to get this right from the beginning. As we're talking about advanced concepts today, still it means avoid many-to-many, avoid detached tables, avoid key value pair, but that's exactly what I will talk about today. So the talk about today is about advanced things, about rare use cases where you have to reach out to those things because there is no other possibility. And then it's good that we have things like a many-to-many relationship available, but the default should not be. So my important thing to tell here is don't take this talk as an excuse to not model a star schema. So we will see things which are not fully a star schema or only half baked because like the don't have a 1 hour for the full demo, but I want to show you several things. So what we will talk about is multifact models. So a model also called sometimes a universe, because a star schema, the star schema, there's a fact table in the middle, and then the dimension around looks a bit like a star. At least this was what Kimball thought. That's why he came up with this name. And a multifact model could also be a universe, because you have then multiple stars in this model. The most important thing is that it should have at least one common dimension, because if it doesn't, then it doesn't make any sense to put it in one model in one Power BI file. We'll talk about that. And what we will see there is that usually the reason why you have several facts in there is because the granularity is different. So the dimensions connected to the facts are different. And then the question is, how can you connect the data from the one table and combine it in one visual with the other table? That's what we talk about here. We also talk about many-to-many relationships in this case. Then we will talk about the detached table. A detached table means it's a table and there's no relationship at all to the other tables. You should strongly avoid this, but there's certain use cases where it's good to have this as one tool there, but not as the standard tool. So that doesn't mean build models without relationships, even if you could. And the last one is the key value pair model, which is not really a model, right? Because it's just one table with a key column, like name, salary, birth date, whatever, address, and then a value column, which is then Bill, Seattle, some date, whatever. And this is sometimes it's used for applications because it's really easy for application developers. It's more or less schemaless. Yes, it has a schema, a key, and a value. But if they want to add attributes, they just add rows there. They don't have to change the schema of the table. And that's what we look for. And again, this is the solution I present is to convert this to something useful because usually we would not take it as a key value pair model into Power BI or analysis services. So multi-fact models means more than one fact table, also called as a universe. And usually the reason is because it has different granularity. So the level of detail is different in those tables. They should have at one least common dimension. And what I think is that these multi-fact models will become much more common as soon as this, sorry for the long name, but this is the actual name of this feature, direct query mode over Power BI and analysis services. Currently, this is in preview since December 2020. And this feature allows you that you connect to not only one Power BI model or one analysis services model. Currently, you can only connect to one, which is called a live connection. But with this, you can convert this to a direct query and then combine a connection. So you can connect to this Power BI data set and another Power BI data set. You can also load data if you want, and you can also directly query a relational data set. So you can combine everything here. And of course, if you connect things, then maybe you also have different fact tables there and there. So you end up with a universe. So it's really important to understand the consequences of those multi-fact model to make this feature also shine in your use cases. So the use case I picked for this is a budget. It could be anything, right? I use the budget because I hope most of you can like relate to a budget and that the budget has a different granularity, right? Your actual data, that you have timestamps in there, so you know things by date, you know the actual customer, you know every detail of the product, whatever. But the Dutch budget is maybe on a different level. You only do the budget per year or per month, but certainly not per day, maybe, and not per timestamp. Maybe the budget is not on product level, but only product categories. Maybe you leave out the customers totally. So you have a customer in your, of course, fact table if you track sales, but the budget is not related to customers. So there's a different granularity. That's why I picked this as an example. And there's three solutions I came up with, which I want to present in the next few minutes. The one is treat_as. This is a DAX function called treat_as. So we're treating something as something else. When I first saw it, I thought this is a Greek goddess, Triatas, or what? No, it's treat_as. We will talk about the many-to-many relationship, and the solution finally I came up with is the bridge table. So click here next, and then not here, and then I open the first example. Is this open? Yes. I'm sure I cannot open. Of course you cannot. So where is this? This is under treat_as budget. Sorry. Obviously I changed something here in my links, data modeling, and I have the, what was it? It was the, I'm too dumb. Long day again, it's evening for me. So budget treat_as. So here we go. Budget and the treat_as thing. This is this one. It's already almost 6:15 in the evening. I had a full 8-hour workshop already behind me. So I don't want to update here. So what we have here is, yeah, we see a little bit of the model, right? This is not the model view. This is just a report. And it's really that simple. So I have a sales table with 4 sales entries for 3 different days in June this year, different products referenced here, and different sales amounts. And then I have different products assigned to different groups. Group 1 is A and B, 100, 110. That's the first 3 sales. And then we have group 2, 120 and 30. Only for 20 we have anything. For 130 we don't have anything. And as you can see, I pointed out there's a relationship in between, but there's no relationship between the product and the budget. Take a look at the details here. So what I have here is I have two fact tables. One is the sales and one is the budget, right? That's the facts. And then I have, okay, there's an echo here. Can you please turn off your microphone? And then I have here the date table, and the date table is fully connected to, of course, to my sales table. And in this example, also fully connected on the day level. Of course, I know that a real budget is not on day level, so you would have also to assign something here or think about something here. I just wanted to keep this as an educational example, simple. So the only problem we're having is here the connection between the budget and the product, because there's no connection. The reason is the product table is on product ID level, of course. And I have a product ID in sales, but I don't have any product ID in budget. I have a product group in here. And I could connect this and end up with a many-to-many relationship. But first, I want to show you something different here. So the consequences of not having any relationship is the following. If I build a report here, I have the month out of my date table. I have group 1 and 2. And if I take a look on the sales amount, 33,000, that's the first three numbers, right? That's group 1, 3,000 plus 20 plus 10 is the 33. That works fine. And group 2 for June, the sales is, of course, the 15,000 from here. And those two numbers sum up as 48,000. Perfect. That's what would we expect. The only problem you see, and what we maybe would expect if there's no relationship, right, then we're maybe in troubles. But what you see here in the budget, that we have 2 times the same budget, that might be right, but also maybe this is wrong. And certainly there's something wrong, because 27 plus 27 is not 60K. So there's something wrong here. So what about those numbers? If you take a look at the budget is only for group 2 and group 3. So no budget for group 1. But we have a budget for group 3. And then there's the date for the June. We have the first 2 rows, and for July, which is not appearing here, right? We have other budget. As this is filtered by date and the groups, only the date and the groups appear here, which are available in the product table and the date table. And that means also, as there's no connection from the product to the budget, the group here is not filtered by the group from here. So we see the same number here, because for June 2022, so those two numbers, this is 27, right? 20 plus 7 is the 27 we're seeing here. And this is repeated because June appears 2 times here. Of course, there's a different group, but the group is not filtering the budget. That's why you see double the same number. But we don't see anything from July, because July is not listed here. And the sum of the 60, always important to remember and to repeat and think of, that the sum, the total, is never, ever, I mean, never, unless you really enforce that it's calculated like that. But usually the default behavior of DAX and Power BI and your calculations is not that it's summing up those numbers. The difference between the detail and the total is always that in the total, all those filters are missing. So the total is different because there's no filter on group 1 or 2. That's why it's showing the 48. So it's not filtering on anything of this. The problem we're having here with the budget is it's filtered on, like this is only filtered on June, but not filtered on the group. That's why we see those double numbers. And the 60,000 is 60,000 because it's not summing up those things, but it's summing up all the values from the budget table. Because there's no filter in the total, there's no filter applied to the budget table. And the 20 plus the 7 plus the 25 plus the 8, if you're fast enough, you can recalculate this in your mind, is 60K. So that's the problem. That's the what we have. Of course, we cannot publish a report like that. So the first solution is using 3DES. So let's first concentrate on the solution, what I see here. So with 3DES, whatever this does, we'll take a look later on. We see that for group 1, we don't have anything. For group 2, now it's filtered. We see the 20. Let's remember here. So on group 2, for June, we have a budget of 20, and for July, we have 25. And for group 3, we will have something different, but the 25 is also important here. And we see also for July, for group 2, we don't have any actual values, but we see the 25 here. And the sum is somehow correct. It's summing up the numbers we're presenting here. So it makes sense within, but we still have a problem. It's not showing up group 3. But that's the next step. Let's see how this 3DES works. So I created a measure here. That's a measure I show here in this column. And this is, again, just using the sum of the budget, but doing something to it. So if you never heard about DAX or never about calculate, so calculate allows us to put in as a first parameter an expression. This could be just a measure or an expression like here. It could be very simple, very complicated. Here it's very simple, right? Because we're just summing up the budget. But then we're asking for something. Don't just calculate it like you would it by default, but do something different. Change something in the behavior. Change something in the filter context, if you ever heard about that. And the 3DS means please take the values from the product group and apply whatever values you currently have. That means in this line is group 1, in this line is group 2, in this line is group 2. Take those value per calculation and apply it upon as a filter on the budget group, on the product group. So we're creating with 3DS, we're creating a relationship, a filter relationship on the fly without having the filter in the model. So this is a first good solution, but we still lack the group 3, right? And what we also have to think of, if you create relationships in the model, it means that some kind of index is created in the model behind the scenes. You're not seeing this unless you use Vertipack analyzers or some data management views to see this. But this means there is some performance improvements if I actually have those filter connections. If I don't have this, it might be slower. So there's some danger with using 3DS. If the cardinality of the tables is small enough, no problem at all. But keep this in mind. Don't throw away all your relationships and just use 3DS, because this might be a consequence in your report, in your performance. So if I go back to this one, so here we don't see the 3DS, so this is still the error thing here, the thing that doesn't work. I just want to show you. I could also go here for the product group and create a relationship by just dragging and dropping the table up there, and then we get this hint here. It's not an error message. We can just click OK, which tells me the relationships cardinality is many to many, and many to many is something you should avoid. It's also like here explained, because there could be some consequences out of that, right? Either there's there is a data quality problem. If you would expect that like the product group ID is unique here, then it will put it out, but it's okay. It's not unique here, it's not unique here, so we take a many-to-many relationship and then create this. And this, by default, is always bidirectional. We could argue about that. I'm not really interested in filtering from the budget to the product, so it would be enough to make this a single from the product to the budget. So we could keep at least we could keep a single directed filter, even if we have a many-to-many relationship. If we jump back, we see the same effect here. So either we use many-to-many relationships, or we use 3DS, so we could have complexity in DAX with 3DS, and a simple model, there's no relationship. Or we could have more complex model, so to speak, by adding the relationship there, having a simple DAX statement, because this budget is just the sum, there's no calculate, no 3DS involved, and I get the same result, unless for the 60,000 here, and the problem that I still don't see the group 3 here. So the solution I go for is the next one, is that I introduce a bridge table. This is for several reasons. You see, like you can use the many-to-many relationship, and in there's some like sweet spots where the many-to-many relationship might be even faster than the bridge table at rare occasions. So this could be also a performance tuning thing that we change between bridge table and many relationship. But mostly I create this relationship not directly, but indirectly. As you can see here, now it's everything like expected. I see my months, I see all my groups, including group 3, and I see also the budget here, and those numbers sum up to 60,000. So this is what I would go for. And I created this solution via a bridge table. So the bridge table means I have a table in between bridging this many-to-many relationship. So I split up one many-to-many relationship to two one-to-many relationships. And this is what I'm having here. How to integrate this product group table? There's several ways of creating. In this special case, I made it just easy. I made up a DAX calculated table. So create a calculated table in the model and then pass in this. So I'm looking for the distinct values of the product group for the budget table. I'm also looking for the distinct product groups of the product table, union them. So I just take one list and the other list, take them underneath. And there could be products for sure. Group 2 appears in the first and the second group. So I apply another distinct. So I get really a distinct list of my product groups. And if you take a look here to this product group table, very easy, very simple. You can see here, this is like group 1, 2, 3, a distinct list of those groups. And this I can then stack in between and have only one-to-many relationship and only have single-directed filters. So this would be the solution I would go for to avoid the many-to-many relationship. Any questions? The recording should go out later today. Okay, no questions so far. Jumping back to the slides.
Just as you said there one question popped up.
Of course.
Is there any limitation on the virtual connection anyway? I mean, row number limitation between the two tables, for example.
No, I'm not aware of, because of course there's always a limitation in terms of how much memory you have. So you could hit some memory limits on physically on your machine, but logically I don't think there's any limitation. To be honest, I use the treatise for some reasons. I don't think I have this in this example as an advanced example, but I had to use treatise in a certain case, and there were one of the tables, like the dimension table, filtering the effect table, had 1 million rows, and I had to use treatise, and even there the performance penalty was neglectable. But of course, it depends on what's big or many rows for you. I consider like million of rows. This is some point where we have to think about performance. Maybe everything below 100,000 rows usually is no problem at all. So you can do anything to your model and it will work. The only problem is you never know when will it or will it not grow over the certain limits, and then you hit maybe performance issues. Oh, didn't want to press escape. Does this answer your question? Okay, thank you. Very good.
I have a question.
Yeah,
someone,
of course.
can you hear me? You know, when we first saw the demo, I was thinking that it might be helpful to create an actual dimension table on the product group.
Mm-hmm.
It is what you did. It essentially did the same thing, but would that have worked as well if I just created another table that would only have the unique groups and maybe an index?
Yeah, but that's exactly what I did, right? The bridge table is exactly the table you're describing. I mean, it's not a classical dimension because like it's filtering another dimension. So the product group is filtering the product and it's filtering the budget. But this is exactly what you described, right? This is a distinct list of product groups. It could be also an index. There could be more information in it. But basically, that's exactly the table, right?
Yes, but I would have done it a different way. Would that have affected performance, or would it have accomplished the same thing? I probably would have gone into query editor and just created another table.
Of course. Yes, you can also create it as Power Query. I tried to use data warehouses in my solution, so I would create it as a view or query in the source system. Doesn't matter at all. It doesn't matter really how you create this table. As long as it's created, it's there and then it's used. And DAX doesn't care where the table came from. It's a calculated table in DAX, or is it coming from Power Query? Is it a direct query table? Is it a table from some other sources? DAX doesn't care about that. As long as it's stored, the Vertipack engine, the storage engine, just makes use of it, and there's no consequences. There's no difference in flavor or whatever.
Thank you.
And then Ben comments here, I used readers on more than 50 million rows. Probably not the best thing to do, but it worked fine. Yeah. So still, be careful with that. So maybe Ben and me were just lucky, and when we used that, there could be other maybe parameters or whatever, but keep this in mind. Perfect. Any other questions?
Nothing showing up.
Very good. So this is the warning here. Yeah, like 3DS is a virtual relationship. This looks fine, but active relationships are much better. That's what should stick in your brain. So make active relationships as much as possible. And sometimes I use like inactive relationship, activate the materials relationship. This is also faster because even if it's inactive, there's still this index there. But sometimes you can't even have these inactive relationships and activate them. So then you have to reach out to treaters. Stuff created in the Power Query is usually fast. Yeah. Guess bridge table within query would be more efficient, but not sure. Danny, I know what you're pointing out. If you get really into depth, then the thing is, that when things are loaded into the Vertipack engine, the Vertipack engine applies something like row length encoding. I don't have time for getting to the details here, but it means that the order how the data is loaded into the Vertipack engine matters. And the Vertipack engine does try to find the best order of the rows to make the compression as good as possible. When it's then loaded and you make a copy of or you just create a DAX calculated table, this is not done anymore. So it's not reordering things. And this is the reason why a calculated table or calculated columns might be not as good as compressed as if you load them with Power Query. But you can remember there's a video out there from Alberto Ferrari, and he pointed out, yes, this is true if you just look at the column, but sometimes you save on the column, but then another column is much bigger because of the other approach. So this you don't should overestimate the consequences of calculating them in DAX or Power Query. I try to push things as early to the source. So if I can already get the data as I need it from the data source, fine. If I create a data warehouse, fine. Then the next thing would be Power Query, and the last resort I use is DAX usually. But if you feel more confident to use DAX or you feel more confident to use Power Query, please choose any of those. It's better to model it right with DAX or Power Query than just not modeling at all. That's the important thing here. Virtual relationships don't last long. Yeah, maybe. Yeah, if you take a look here, yeah, there could be a problem. Yeah, Jeremy is pointing out this. So detached table is the second thing, and time-wise, yeah, we're doing okay. A detached table is exactly what the name suggests. It's detached. There's no physical relationship in the model view between the table and the other thing. Of course, there's some real world relationship. So there's some, otherwise I would not put it or refer it here. So there's some connection, but not in the model view. So no connection at all. Yeah, we're not talking about having bridge tables or something, or many-to-many. And the reason why you would it, or that is the only reason I would it, because the model view does only allow you for equijoins. So equijoins is this term that the product ID is in a sales table and there's a product ID in the product table, and they have to match. They have to be equal. I cannot ask for a relationship where the quantity is greater than this value and lower than the other value, and then I connect those things. So I don't know if you write SQL, for example, a word statement, you could just do join and then on and put any predicate in there, any condition. This could be between, in, whatever. But Power BI does not allow us to do an analysis services. When we do the connection, it has to be an equijoin. It has to be equally. And sometimes this is a limit. This is a problem. And then we can reach out to this idea of detached tables. So use case here is binning. That means that I have I'm not interested in the individual values, but I want to t-shirt sizes. I want a big, small, large, medium, whatever, something like that. So put things into bin because I'm not interested in the very detail. It's more like getting a rough idea what the data is about. And there's two ways of modeling this. One is to create a dimension with all the distinct values available. So if the quantity can be something between 1 and 100, I create a table with 100 rows, 1, 2, 3, 4, 5, and so on, and then add this small, medium, large into it. Or you could even have just a small table with the from until. So if the quantity is lower than 3, then it's this. If it's between 3 and 5, it's this. And if it's bigger than 5, then it's large. So let's see if I can start it from here. Most probably not. Yeah, if the other one did not work, yeah, this doesn't work either, of course. That's the consequences here. So there is, I think this is in DAX, and there is the binning somewhere. Yes, at least I'm lucky from this perspective. So the first approach is that I have this bin table with all the available values. Assume, yeah, now we see it. So again, very simple example, similar to what we have seen. Only 4 rows in the sales table makes it possible for us to calculate the things in our mind, to understand the thing. It's not because it's an issue with bigger tables, it's just to make it easy to understand what's happening here. So in this bin table, I have a table with all the values. So 1, 2, 3, 4, until 6. And then beside that, I name what the bin should be named. And then I can apply this. So I can have a combination of this table and the other table. And this, both tables are related to each other. So there's the sales table and there's the quantity. So it's not the product idea or something like that, but it's the quantity I then connect between the sales table and the bin table, which looks like unusual, right? Usually we use keys or unique identifiers or whatever to connect things, but we can also connect things by quantity. And that's what I'm doing here. And this is working fine, brilliant. We have an active relationship. It's really fast. And then we see like the products, and then we see how many products do we have in which area. So middle, it tells A is only 1 because product A was only sold 1, and the quantity of 3 is middle. Then B, we have low and middle because we have 1 and 4. 1 is low, 4 is middle. And for C, we have 1 in the high area because 5 is in the high area. And also the totals, everything work fine. The only disadvantage is here, 2 things. One is we have to actually build this table with all those values. This can be many. And maybe there's also some guessing in it because maybe currently the highest quantity we have is 5, but there's no guarantee that somehow the next order is on 100 or 1000. So we have to think of what kind of numbers we want to add here in this table, how big this table should be. Usually creating this table is rather easy. Either you just make up an Excel spreadsheet and you can then grab like 1, 2, 3 and then grab this and create it and write the names there. You could again use DAX. You could again use Power Query to generate this. Use your data warehouse. There's many possibilities how to create it. And again, doesn't matter how you create it, as when it's loaded into the data model, it resides inside the VertiPack engine and it's fast because it's already loaded, no matter where it came from. So the DAX table, this would be this one, for example. So here I created this table via DAX. A little bit more complicated DAX or not. Looks more complicated than it is. So what I'm doing here, I go through my quantity table and add a new column bin. And for the bin, I decide what the quantity is. So if the current quantity of this table is below 3, I assign low. If it's below 5, I assign middle. And if it's anything else, it's high. So this technique with through here. So usually you have to put in like a value and then compare it. If you put in true, you can then have conditions here because they evaluate to either true or false or blank. And if they are true, then this is returned by switch. And then I also have a sort order here. So this is how I created this table. And this table looks very much the other table, right? So the DAX table looks very much the other table, unless it's, oopsie, what's happening here? So the only difference here is, 3S, that's the wrong thing. I do not want to have this open. Don't save. So here we go. The only difference is I don't have all the quantities. I just pick the quantities available in the fact table. Of course, creating this table can be very expensive because if your fact table is really huge, then also, of course, scanning through the whole fact table is very, very big. So there might be advantages, disadvantages. The advantage here is every quantity available in the sales table will be listed here. The disadvantage is we are depending on rescanning the fact table. So be careful and try this out before you generate it this way. And we could also, of course, create it in Power Query. Same thing. I have Power Query running here to scan through the bidding table. This, I think. And of course, there's something. The path is wrong because why is the path wrong? I'm afraid I cannot show you that. If there's time afterwards, I will keep this open, then I will show you the solution here. Don't want to spend time in bug fixing here. The other thing is not having a physical table with all available values. And also the disadvantage with this is you have to create it. And the second one, talked about 2 consequences of this table. The second one is maybe there's not a distinct list of values available. Think about decimal numbers. So maybe there's only 2 decimals available, then you can create it like that. But like there could be more decimals, so there could be like an infinite amount of values in between, and then it's you cannot come up with this table. You will have gaps, and when you have gaps, then the things are not assigned to one of the bins, but will show up as blank because Papi are not deleting anything, but showing it as blank. So in this way, and also maintaining would be easier. So let's concentrate first on this table. So instead of having a list of distinct values, I build a list just of distinct bin names, low, middle, high, and then pass in like what's the region, right? So I don't care how low it is. It might be even negative. It might be 0. I don't care if it's below 3. So exclusive, this means below 3. 2.9 is okay, but 3 is not low. 3 is already middle. Below 5. And if it's 5 or bigger, I don't care how big it is. So this is also like limitless. It can be very low numbers, it can be very big numbers. I'm not having any troubles in here. And it works like the charm. So this is the same thing here. Now I'm using the bin range table, and then also things are assigned accordingly to the thing. What we have here is a little bit more complicated duck. So I try to walk you through in a couple of seconds or minutes, make it fast but slow enough to understand. So the first thing is SumX. SumX is an iterator function which is iterating over a table parameter. So the first parameter is this long expression here. All those lines is just the first parameter, and then a 1. So when I get a line in here, I don't care what the content of this line is in this table, this filter, I sum up 1. So I'm counting things. So the goal of this filter is now to show me something if the product is part of this bin. If it's not part of the bin, return nothing, then it's not counted. And then for this filter, we have 2 filters. So there's one filter here and there's another filter in here. So I'm iterating 2 times over the model. First filter is iterating over the sales table, and for every row in the sales table I'm iterating over, I'm calling then a filter on the bin range table. So the sales table calculates the quantity as a variable and then reuse this. So I'm then checking, I'm iterating over the bin range table, checking if there is a quantity. So if there's no quantity, I'm not interested. Of course, if there's no quantity, it's not falling into anything. If the quantity is bigger or equal to the low range, or, so this is an or operator, or the bin range low inclusive is blank, this is this guy here, then I'm fine. Then it falls into the low region, right? Or whatever region I'm at. And it has also be lower than the high exclusive, or the high exclusive is blank again. So if something is, for example, 2, it falls under this region because, yeah, this is blank. So I'm not caring about greater equal, but this is blank. Okay, so this could be a candidate, and 2 is lower than 3, so it falls in this region. It would also iterate over middle, but 2 is not greater equal than 3, so it's not falling into this region. And then I'm checking if this bin I'm returning here, if this is not empty. So if I found something, then I'm returning something, and then this row is counted for this filter. Does this make sense? So again, we have a much easier model because there's no connection here. So there's no connection. That's as it cannot be more easier, right? Avoiding any connections, any confusions in filters and so on. But instead, then we have a more complicated DAX. And whatever works for you best, pick what works for you best. Any questions about that before we jump over to the next thing? We keep this open in case we have time.
Questions at the moment.
Okay. So the last thing I want to talk about is this key value pair model. Not as a goal. The goal should not be that you model a key value or have key value pair models, but sometimes I come or the request is to get this as a data source, and then I had to think about what to do with this. And the concrete example was for insurance company. So they collect. If you apply for the insurance, they will ask you several questions, like it's a life insurance. Are you a smoker? What's your weight? What's your income? What's your job? Whatever. And depending on certain answers, they will ask you other questions. So they have a tool for that to assist the claims manager and the client manager. And that means that they have lots of attributes. So there's like over 800 attributes they collect, possibly asking you. Of course, not asking all the attributes, all the 800 questions, everybody, but it's different, and they have like the core thing of this application is a set of rules when to do what to find really out the necessary things. And so the rules could come up with much more attributes, which are not currently the data, but in the data I only see the current things. So it happened that like I maintained this manually, I pivoted everything, and then once in a while they came up with there's an attribute missing. I said, yeah, because it was not there when I modeled the thing, right? So I looked it up again and then remodeled everything again. Yes, I'm going to share the slides, and I can also share, of course, the demo files. Yeah, watch out. Yeah, I will send it to Kevin, and he will make sure to share it with you. So theoretically, this key value pair model is just a key and a value. So the key is maybe title, and then you have like the book title, and then there's like a price, PRIC, and then you see the number, what it costs in US dollars or whatever. Practically, there's two more columns. There's also an ID column because I want to like cover some attributes together, because there's one book and there's another book, and the first book has different title than the other book. So there might be some ID column. And hopefully, because this makes things more dynamic, there is also a type descriptor available. So I know what the content should be, because physically the key, of course, is a string. And also the value has to be a string, because if it's not a string, I could not put in a date and could not put numbers, and of course strings also there. So the actual data type of the value column is a string. The content might be a date, but it's stored as a string. So the type descriptor telling me that the content of the value is a numeric or a date or whatever will tremendously help me if I want to build this more dynamic. And why application developers like that is because it's extremely flexible. Because if there's new attribute, they don't have to change the schema. They don't have to add a column to the database and usually to the table. And sometimes I have the impression that like application developers not really love databases. They have to use it, but it's not like they're interested in modeling things or whatever. So this is easy then for them, because they just add another line with a new attribute, salary, and then put in the salary. The bad thing is that the bad story here is it's extremely hard to build reports on that, because like who wants like the long list of 2 columns and then pointing out what's the salary? You cannot really add up things. So this is really, really hard. So what we need is that we have to pivot it to make real columns out of that. And of course, the second step, which is not part of this demo because I will run out of time otherwise, of course, then you take this as like this is the Franken table, so to speak, and then you make the star scheme out of that. And I will show you the first portion, how we can convert this key value pair into a normal table with columns and rows. So not in here. I want to go here, and then I have my key value example. It's in here, and this is the last demo for today. This. Showing a few seconds of silence. I talked all day, so this feels good. So the data source is this table. So this table has 3 columns. We talk about the type later. So there's this ID. So these are together. So I have a city, Seattle, and then the other one is also in Seattle, and the third one is in Lakoven. And then there's one purchase in this date, and the other one has a first purchase date. So this is the basic thing of this table. And this has one really cool advantage if we're only interested in the counts. So I can build a report like that. So I have now, I can select the different keys for my columns and different keys for my rows. So I can combine and ask for, please show me on my rows all the names. That's what the name is here. And in the columns, all the cities, and show me the counts. So how many bills do we have in Seattle? How many blah, blah, blah. So if you look like on patterns, is the like relations, is the correlations, this could be a really cool thing, but this is the only thing. So I would not build it. Maybe I would build it to satisfy those reports, but the usual reports don't look like that. And then you can just change things here. So I can like look for the first purchase and then see all the purchases here. Or maybe this is too long. So I put the purchases in here and put in the zip codes there. So this is extremely flexible seeing things here. And I built this by having the source table 2 times in here. So I loaded 2 times. That's a disadvantage here, because this slicer is going on the first one, showing all the keys from the first one, and the column slicer is on the second one. And here in between, I have the columns 2 times, one the rows, the value from the first one, and one the value from the second one, and then I count the IDs of one of these. This is how this is built. So this could be a nice thing. But what I want to show you is all the problems you get with the key value pair, because we can of course build a matrix and put the ID on my rows, the key column on my the key on the columns, and then the values on the different things. And we see two problems. One problem is if there's more than one value available, I have to pick one, first, last, or I can only count. So Pabi asked me here to pick the first one or last one, because they could theoretically two names for the same ID. And the other thing is, what we can see here is like the number format here. This is not a number because the value is a text. So it's like numbered like that. And if I would, for example, turn on the subtotals, and now you see the reason why I turned off the subtitles, because the totals would just show like the first, alphabetically first city, the first date. Yeah, okay, this could make sense. The first name doesn't really make sense. And for numbers, it's really weird. It's useless, right? Why is this the first number? Because alphabetically, 1900 comes 4200 and also comes 5 blank blank blank. But this is not how we can build reports, right? That would be like, yeah, your contract will be terminated immediately if you present something like that. So what I can come up with is that I use DAX for that. So now I have the same solution here, measures on the source, and I created measures for the city and the revenue. So what did I do here? So let's start with the city. This may be the easier to see. So for the city, I use calculate because when I'm talking about the city, I'm only interested in rows in my table, in my source table, where the key equals city. I'm not want to show name or something else, only the city. And then I have this little bit weird thing here. First thing is this min. Again, I have to decide what do I do if for one ID there's more than one city available. Yeah, I choose the first one. So min is the appropriate or the same thing like the first individual here, first function. And the other thing here, this has one value, is that I'm checking if there's only one value available for the ID column, because then I know I'm in this list and then I show something. The other way around, if I have more than one ID, I know I'm in a subtotal, and the subtotal, it doesn't really make sense to show a subtotal about the city, right? So this is why I only show something when there's a value, when there's one single value for the ID, then I show something, and the else is blank. So that's why I see blank here. For the revenue, the story is similar, a little bit different piece of code. So I do the sum x again. So I'm iterating over the first parameter, this filter function, and then I use the value function to transfer my value into an integer. So value allows you to take a string and convert it to a number. This is what I'm doing here. And this again makes sure I'm not iterating over any and not all the rows of the source table, but only when the key is revenue. So I only do this for the revenue because I'm at the revenue. So that's how you can solve this, but maybe you also already see the problem in here. You have to create a DAX measure for every single attribute. So in my occasion, I would have to create 800 DAX measures, and as soon as there's a new attribute, I would again come into my model and create something in here. Is my screen frozen, or is it sharing different screen, please? So I currently share key value, Power BI key value, and you see a report. If it's frozen on your side, then maybe leaving and coming in again, or tell me if there's a problem on my side, then I can leave and come in again.
No, you're right on.
Pardon?
You are right on, Marcus. Right on.
Right on. Okay, very good, very good. Also, very good for me. Yeah? Bad for Akshara. So what I came up with was a generic idea. So I have this generic thing in DAX, and I think there will be no time for showing the solution also in Power Query and in SQL, but hopefully you get the idea. So generic value means that I have one single measure. Let's first demonstrate this. So I have one generic value in here. I put the ID again here. I put all the keys I'm interested here. I put the keys in here, and then I have a filter running to show or not show different keys in my columns. And then I have this generic value measure where I first define a variable which is a table, which tells me what kind of my attributes, what kind of my keys in my source table are actual numeric columns, because they I have to treat differently from the strings, right? And then I have another variable where I treat the content, whatever it is, as as a numeric column. So I have the same duck statement again here. Remember the value here, the sum x over the filter, where I say key in revenue. But now I'm not saying key equals revenue. I say key in numeric values, which might be a list of whatever column names. So I can treat this as a parameter. I don't have to create something for every attribute, but only if there's a new numeric column, I have to add a line, an entry in here. The non-numeric, it's just the same thing we just have seen. There is if it has one value, and I don't have to prove anything because later on I just check if it's not numeric, then I show the non-numeric, and if it's numeric, then I return the numeric value. So I don't have to check again with the calculate in here. And that's what I'm doing here. So this is more flexible now, and over the key, I have full control what I want to see. So I can then like also show the name or not showing the zip code or whatever I want here. So this works very, very nice. And I even have an improvement here to get rid of this manual process. So I can make use of this type column. So that's why I named this generic type. So this works the very same. If we add this here and remove the other one, so we're not confused, this works the very same result. Everything is nice. What I'm doing here is that instead of having my variable with a literal list of entries, I'm scanning my source table. So I go through my source table, filter my source table, where the source type is in, and then it's not so important what's the content of this. So in my example here, I use the data types from Power Query. So number, currency, percentage, int, 64.type. But this could be anything. So in my in the client example, in the real world example, they sent me up numbers, and then no 1 is a string, and 2 is a decimal, and 3 is a whole number, and 4 is a date, whatever. I don't care. This is what you have to put in here. And the rest is then taken automatically, because if you put all the numeric columns in here, again, I get a list of those numeric columns, which I use here, and now I'm totally flexible. So if there's a new entry, a new row in my source table, as long as it's one of the data types I'm expecting, then it will show up rightly here without any interference, without any necessary change. Okay, any questions up to here? So we can jump either into the other Power Query again to fix this, or I show you Power Query here, or open up for questions, or give you back 4 minutes. So there's three options we're having here.
No. Oh, just when you ask, everyone goes in.
Yeah, very good. The if and has one function to get better than the selected value function performance point wise. No, I think this is it's the very same. So selected value and if has one value ends up in the same thing. So this is what Jeffrey Mang and also others call syntax sugar. So you're writing your syntaxes differently, but what the engine behind does is the very same. So I'm not sure why I use the if has one value and not the selected value, because usually I prefer the selected value. So let's see. Let's open up this measure again. Here's if has one. The thing is, I didn't use it here because with the selected value, I could only have like one column, either the ID or the value. But what I'm doing here, or also in the other one, like in the city, what I'm doing here, I'm checking if the ID has one value, and if the ID has one value, I'm returning the value column. So I'm doing two different things, and this is what you cannot do with selected value. With selected value, you can also point out if there's one value in this column, then it will actually return the content of the column. So I would see the ID and not the value. So that's the reason here. Hopefully answers your question. Okay, other questions? 2 minutes to go. Remember, this is not, I mean, if you're watching the recordings, of course, this is a recording, but everybody now live here, this is not a recorded YouTube video. You can ask questions.
Doesn't look to be any more questions, so go right ahead.
Very good. either I fix my problem in here. Here it is. I think. No, it is not. I can't remember. What was the path here? Yeah, it is. It is. So this was the thing I just promised to use my last minute I have for showing you this. So I also have the source table in here and then used all the transformations available in Power Query to transform my actual fact table to only get down to those things. So I group them by the thing. So I'll also get the 1, 3, 4, 5 with middle and so on with custom things in here. So the custom thing is then evaluating if the quantity is lower than 3, then it's low, and so on and so forth. So you can build this with any tool, whatever is convenient for you. And now back to the studio to Kevin.
Awesome. Actually, there we can go till 15 minutes later if you have anything more.
Okay. Yeah, I'm okay with that. If you give me 50 minutes more, I will talk 50 minutes. You know. Yeah.
Let's do it.
Be careful with that. Yeah, very good. Very good. Yeah. So everybody who wants like to enjoy the day or the afternoon or whatever, thank you very much. Everybody who wants to stay, then we continue for 50 minutes. Oh, sorry, I thought it's like 60 minutes talk. I saw the invite is going to the quarter past the hour, so I can show you more the key value, if this is fine for you.
Let's do it.
Let's do it. So I did show you like the whole thing with DAX and even with DAX. And when I created the solution for my customer, for my client, I did everything in SQL. So we have a SQL data warehouse, the Azure SQL DB, and I have my procedures running and everything. And then I thought this is a nice thing maybe to show at user group meetings or in my trainings. And then I thought, yeah, this should also be doable in Power Query. And then I built everything in Power Query. And I thought maybe you can also do this in DAX. And I was surprised how far you can come with DAX. And the question is, should you do it DAX? Should you do Power Query? Should you do SQL? And some years ago, I would go for SQL, of course. Use your data warehouse. But on the other hand, maybe you don't have a data warehouse. Maybe you have a data warehouse, but you don't have access to it, or you don't have access to the resources, to the people who can actually write those queries. So recently, I changed my answer to do whatever you feel confident with. Of course, we just heard that like Power Query, this is like a little bit more optimized if you load it than we do it in DAX, but usually this is neglectable. And it's much better that you, when you're, I'm not sure if you use a beginner or if you mature Power BI users, I'm not sure. But for beginners, try to concentrate on one thing. Try to learn DAX. I would say learn first DAX, because you need DAX if you do the measures. Some things you cannot pre-calculate in Power Query or SQL, so start with DAX. And then use DAX also for the data shaping in here. Maybe it's not 100% optimal, but it's way better to shape it in DAX than not shaping it all. And if you feel like confident and in DAX and then be like interested in more things, then start learning Power Query and do things in Power Query. So that's what my approach in the meantime is. Yeah, Roche's maximum, of course. Yeah, push everything as early as possible. This still applies, but what's possible might be different for the company, might be different for the person, and what works for me does not mean that it works then for my clients. And sometimes I build like the first thing and then hand it over to my client. So it's important that the client also can maintain the solution. Aren't those two different things? I believe if and one has value allowed to not display a useless total where a selected value is selected in a filter or something. That's ending up in the same thing. If I quickly enough understood your question. Yeah, also if has one value, it can be different from the selected value. It can be the same, but how I use it here, I use two different columns, so it's not the same, and it cannot. Okay, yeah, what answer to quickly? Okay, then jump to Power Query. As this just worked as a sham to jumping over to Power Query, let's do it also here. So let's show you the solution in Power Query. Again, here it works. So the path is right here. So again, I have this source table. Remember the same table we just have seen, which has this ID, the key, the same thing. We have this type in here, which is not so important. And usually, if I would transfer this, I would do the following. So I would like, duplicate reference or whatever, or directly do it there. I just want to show you what I do. And then I would pivot the thing. And I always have to, in SQL and also here, as I did show today how to do this. I use this example also today in my workshop. So hopefully I can immediately click the right things. So I think click the key, then I tell her that the values column is the value, happens to be the same name here, and then I want to see the minimum of the value. I don't want to see calculations and counts. So I then transfer, I pivot the thing, so everything which was in the key column is now something in my is a column in here. I didn't need the type. We can get rid of the type because it doesn't make sense to have the type here anymore. Remove. Here we go. And then everything in here. And maybe I should have put it first. I should first remove the type and then do this. So I screwed up my demo. Still, if I just did it some hours ago. So now I have my columns in here for my 3 IDs. Hopefully this is readable for you. And the only issue I'm having here is that like the revenue is still at a text type, right? So I have to change this here and tell it it's like a number, whole number, whatever. And also like the zip code not, that could be treated as a text. And this would be a date. So still, if I pivot it in Power Query, if the data type is different, I have to go through here and manually change the data type again. And I'm lazy, or like Patrick points out, Patrick Laban, he's not lazy, he's efficient. So I want to script this. So I thought about, is there possibility to change the types, the data types in Power Query with a Power Query script? And it turns out my research was successful. So I found something. So as you can see here, again, it's the same thing, a long script. I will walk you through this in a second. We also have the ID name, and the data types are right. And I promise you, I did not change the data types here. As you can see here, this is only change type for something arbitrary, right? This is not like change the data, and it would change to binary. There's no binary in here. So this is not the last step I did here. So what I did here is the following. The first steps are the same as I just pointed out. So if the source, I removed the type column, I changed the type to make sure that this is an integer, this is a string in all cases. I think it was already previously. And then I pivot everything. That's the starting point. And then I have like some edge in my script. So the next step is not using this table, but it's just collecting all the column types of all my keys and their column types. And then I have group of 4 transformations: text rows, text row keys, text row columns, changed type 1. And then repeating, integer 1 type, and so on and so forth. Change type 2. Then for the numbers, then for the currency, then for the percentage. So I just copy and paste the thing. And the difference here is the following. In this step, again, I'm not using the full previous steps, but I'm building up on the column types, which is this step in here, and filtering it only to columns of type integer 64 type. Again, if your source system doesn't deliver Power Query data types, but something else, then the filter in here would be something else. So this would be 2 or whatever, or integer or whole number, whatever the text is delivered. Then I get rid of this type. I don't need the type in here. And then I use this for this function, which is, I convert it to a list first. And the last thing is then change type. So this transform column types allows you to provide a list of values. And for this list of values, I provide what I just got from this step in 64 type columns in here. And for all the columns in here, I change them to integer 64 type, or I change them all to whatever currency. And this is how this is built. And of course, you could like make a function out of that and then apply it to any occurrence where you have this. And this is really flexible. So when image adds something, it's not only automatically pivoted, but also the data type are right. So I don't have to do anything except for refreshing my data model. So refresh the Power Query and refresh the data model. So this is flexible, much more flexible. Any questions about the solution in Power Query?
No questions.
So then let's jump over to SQL. So now you have seen DAX, you have seen Power Query already, and I used the last 7 minutes or so to show you something about how you can solve this in your data warehouse, in your relational data warehouse. this here is Asia SQL. This could also be like SQL Server. Most probably there's similar solutions also available in any other relational database. I'm using T-SQL here for creating procedures. Of course, the syntax of T-SQL might be very different. And Oracle PLSQL is much different, so you cannot just copy paste. You really have to rewrite the logic here. But I hope you get the idea. And what I'm having here is that, again, in the relational data warehouse, I have this DTH key value table where I have the IDs, I have the key, the value, and the type. I also have a source column here. It's not important for the course of this demo. And the result is then that I either want to really persist everything into a table. So for the real world example, I wrote a T-SQL procedure which not only pivoted the content, but also made sure that there's a table available where I can persist all the data with all the right data types. So I'm creating a table there and also creating a view, because when I create a data warehouse, nobody, that means not Power BI, not analysis services, none of the reports, none of the report users may access any of my tables. Don't touch my tables. I always expose everything over views. This is so to speak, this is like the API of my data warehouse. So if I change something in the data warehouse, I will change my tables. I will make sure that the view still returns the same content in the same way. And if I make big changes, I might create a new bunch of views and ask people, please change over, and you have to until whatever, and then I can delete the old views. So this makes some independence between the actual data and your reports, your data model, and so on. If you don't have that, then every change in your data model in the data warehouse would impose that you simultaneously to also put the report or the other tools in production. This makes it much more complicated than having this views in between. So the view looks like the same then. And so the very important function, the procedure to create the view is this one. 5 minutes to go. So there's a schema key value just for the purpose of this demo, and then this procedure create view key value. And I think the source is not very important, and debug is also not important for the first thing we see here. Then I define some bunch of variables, so the carriage return, because I want to create nice things. So I have this carriage return and line feed there. I have a variable for my command I wanna run, and then I have those two things, because if we take a view on how the not the view looks like, but where is it? There is this query view. I wanted to show you the view. Here's the view. So like pivoting the thing in SQL is also possible, of course. So what we have is this keyword pivot. So you from something, you might join it with something, and then the important part is this pivot in here, where you have, so to speak, 3 parameters. So there's a keyword, parentheses, and the first thing I have to ask for what kind of value. Yeah, the minimum of the value. We already have to seen this. Again, you have to apply an aggregate function here. This is a must. Then for what? We're looking for the content of the key, and the content of the key is then the city, the first purchase, the name, the revenue, or the zip. And unfortunately, T-SQL and SQL Server do not allow you to pass in a subquery in here. This has to be a literal list. And this is what I hate here, because when new attribute comes, I have to type in something in here. And this is why I wrote a procedure which creates this view for me, which creates this list of try convert blah 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 with the right data types, depending on the type I get, and also this list in here. So this is what this view does. And this is the content of the key and the pivot thing. And then I do a string aggregate over the key and the pivot. The string aggregate is like numbers you can sum up, right? And strings you can also sum up. Like you have like 5 rows with different strings. String aggregate will make sure that you get 1 row with string and then with the limiter in between. So I get 1 value, comma, blank, next value, and so on. So I get all the keys and what I need for my syntax. So the keys is just a list of the keys. This is this one, this portion. And this variable column named pivot is, the pivot is this thing. So min, try, convert, blah, blah, blah with the right data type. The data type I also get from my query. So I derive this. And then at the very end, I have a command where I have this create auto flow, blah, 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 it's commented out because I do not want to overwrite the view. But usually also add this in here. And this comment does not apply to the procedure here, but it applies to the view. Because if I write a procedure where I create an alter view and run this, maybe later in time I also run the procedure again, and this will overwrite everything in the view. So this is also a hint to myself. Please don't touch this view directly. Don't alter anything in here. If you want to alter it and make sure that it survives into the future, please make sure to rewrite this the code in the table. And then I have to select ID, blah blah blah. This is like this part. Select also create, select blah blah blah, and then I pass in the pivot thing, which is the try convert from blah blah blah, min key in, and then I have again my key values, the list of the key values in here. So this is what you can do then in Power BI, in SQL Server. And as already hinted out, I also created a procedure filling, created also a table temporarily with that, with dynamic SQL, and also procedure taking all the data, filling it in to the table. So everything is also persisted in this column now in this pivoted way. And this gives me ending up 1 minute before the last end. So back to the studio. Is there any questions? 1 minute for questions, or it's already over, right?
No questions, it looks like, Marcus, but I am sure someone will be pouring in any second now.
That's the lesson learned, right?
That's right. Maybe that minute you gave everybody extra just threw people off. But as always, great session, Marcus. That was truly awesome. I think I learned a few things. Watch out for and never do again.
Yeah, cool. When it looks easy, yeah. Even if for me, some of the parts were not easy. Like this procedure, this took me a while to like the SQL procedure. This was not something I wrote in one afternoon. Especially the whole solution where I also convert things to friendly names. So so that the full solution also makes sure that, for example, I get the aliases right. So I get capital C or I get a blank in there. So there's a lot of more involved things. Yeah, but it's fun to present it and it looks like easy. Very good.
We'll just go with the idea you did it in like a couple of hours and knocked this all out. It's good.
No, I've been honest here. So reapplying this would take maybe one afternoon. Yeah, but inventing this things from scratch was a bit of work.
Yeah, definitely not a 10-minute, you're done. It's
No.
a while.
Challenging
Cool.
would be
It looks
now
like
if you
everyone is.
it would be challenging if you reduce now the data set. You have an outside connection and then you have a certain row which you then go for, or let's say a column you go for, and then that's reduced afterwards. Then to make sure that you can also in the future connect to that would be another challenge. At the moment you go just forward and you just grow the data, you have more possibilities, but what if one would reduce one of these? That would not be accessible then anymore. So you would
That's
have
a good
to write
point.
that.
Yeah. So what I also use is like I have this this special. Is it this one? Yeah, I think that's the key values.
I knew you have a solution for it.
Yeah. So I also like, because there were some things I could not directly match, because like there were like, if I converted to blanks and capitals, two different attributes would end up as the same attribute, which was not allowed. So I introduced a table where I could have like manually fill in things how I want to rename them, and also use it in the logic. And maybe that's a good point, because then I could just use everything I have and add it to this table automatically. So the next time the data, somebody deletes some data and some attributes are not there anymore. I think this was what you pointed out, right? If like data is missing and then attributes are missing, then I would reduce my model and lose columns. Yeah, there could be a solution like storing this in an extra thing and not rank it in anymore. Yeah.
Perfect.
Yeah, but
Thank
good
you.
point. Yeah.
All right. So with that, it looks like our time this week has come to an end. So folks, Be sure to say thank you to Markus, those of you who have not, and we'll see y'all next time. Thanks again,
next time.
Markus.
Bye-bye.
Good night.